Hello everybody, from your favorite test electronist, Mr. Cute. As you can see, I've inserted here a PIC 12F508, my favorite PIC, because why is my favorite? Because it's not that complicated, it's quite straightforward, and it's kind of easier to program than any other version of PICs, because the other version of PICs, they have some funky registers that you have to select and deselect and swim between them, and it's a pile of shit. From my point of view, of course, it's very subjective. It's how I'm seeing the things. Discussing with my English friend, and he was saying that almost all the microcontrollers these days are following the same logic or the same line of mentality. They kind of all have the same registers problems. I mean, and I said to him, from my knowledge that I have, those registers that you have to switch between them is because of the multiple options per one pin. So as you can see here, you have two here. But there are other pins that they have maybe 3 or even 4 options you can switch, and they can do different stuff. That's the problem. And yeah, so far I managed to put this PIC microcontroller here. In the beginning, it didn't do anything, of course, until I start to program. And I actually start to program it in. Let me bring up this guy. I start to program it here. You see, right now I'm in PIC-C. PIC. So I try to write the code in microchip assembler MASP, and actually I can show you. If I'm opening this, you see it's doing okay, build all, and no, build succeeded, voila. And it's quite a bit of code, not that much. I'm not that good. I am good to a point, and like everybody else, I'm using a lot of references, code snippets or code blocks, and I struggle to collect them, and I'm using them and trying to learn them by heart, but not doing it every day, not doing it so often. I'm quite rarely programming in assembler. I know assembler a tiny bit. I did a lot of tutorials. I am a little bit fluent with the words that is having, the way of doing things, but I'm not really good at it. I wish I was. And this project demands to be good. It's quite complicated. It becomes very complicated very quickly. And what I did here is a start. Is the beginning, and I stayed only on this code probably 2 or 3 days because I had to remember stuff. I had to track back everything, to restart everything, to relearn everything. Of course, much of it I know, and I already made some tutorials, and I kind of remember them, and nothing really is totally new, but I really had to remember stuff, and it took me quite a while, and I actually had to make new files to help me further, and all this stuff eats a lot of time, and yeah, then I decided it's the code that I have to do here. It's way too complicated for my level of assembler that I am. I'm a rookie. I'm a beginner in assembler language. I'm not that good, but I know how to put head to tail a little bit, a little bit of pieces of code. I know how to sew them together, but I'm not that advanced. I don't know all the tricks for sure. So this is it for MASM. That took me like 2 or 3 days probably, and I was kind of enthusiastic about it. But then I come to earth, and I said, well, I have to find something else that is a bit more at my level, at least the level that I understand. So I have this program. It's called CCS. You see here on the top, CCS. No, not CSS, but CCS. C compiler. Actually, it's called CCS compiler. It took me 2 days, 2 or 3 days for this program to evolve. Actually to relearn it, because as with Ensembler, I'm not really used to this guy as well. I use it 1 or 2 times. I made some tutorials like everybody else, and I kind of get the hang of it. I put it aside. I knew I have it, but with all my sincerity, I didn't work with it that much. I'm not professional with it either. but despite not being professional with this program is more closer to higher level of programming, like C# it is very close to C#, that I am proficient. I am very good at it. There I am professional in C#. Well, if I'm not at the top, at least I'm somewhere over the middle. I'm quite good at C#. So being good there, it helped me immensely. It helped me with this guy, which is a C. As you can see in the name, is a C language. It's kind of translating the assembler into C. And what code you are writing here in this C compiler, it is translating it back into assembler, and then it's transforming it into hexa. Both, by the way, this is a little detail. In both versions, in MASP and PIC, so here in MASP, I could get this hex. You see, LCD 3-digit C hex. This hex file. This hex file. This is what I imported it here in the PIC in Proteus, and now is having the folder from and the file, the same file 01. As you can see here in the title, 01C. But it is producing, let's go here, this is the folder. It is producing a hex, where here it is. This is the actual file that is loaded inside Proteus and is running. But both in assembler and in this C version of program, I managed to load the same hex file. Not the same, the respective hex file here. In this case, the hex file that I have it in generated by this C compiler, and I was able to test it here with all the stuff that I have. So far, let me play it if I don't get an error. Yeah. Okay. So right now I have it loaded. The program is showing. So the PIC microcontroller that I'm having it here in Proteus, it is having a program in it. The program that is this program from here that I'm writing it here, and it is showing number 1. If you are making a little bit of abstraction of how things are blinking, they are blinking actually at a very slow speed, at 1 millisecond, I believe, or 10 milliseconds. But in reality, it will not blink like it. It will blink much more faster. Here in Proteus, if I'm putting more speed, it will not show, because it will not show. It will show it like it's not lighting up. But I have to dial down the speed a little bit to actually see them flicker like this, and it is B and C for number 1. Here is number 1, B and C. And let me show you the program a little bit. Like I said, I stayed like 2 or 3 days. I started with very basic code, and I started to build it up, more complex and more complex, and I had to cut a lot of code and replace it with a lot of code that so this is the main void, which usually you have to put your program into it, but I had to make a special function and pass that to the main void. This is when the program starts, the first round, the first thing. And then after program starts, like that, I have a press of the button that is running the same, you see here, around the program, the same function, general function. And then it is this button here. When I was testing stuff, right now is automatic. What you are seeing right now is automatic already. But when I was testing stuff, I was testing it with this button press. When I was pressing this, bringing it to 0 volts or to ground here, like you're seeing here, was running this code that is here. This counter that you're seeing here is very important. Is all over the place. The entire program is full of it. Is depending on it. This count to 6 actually is called counter 6, count to 6. This is how I created the segments that I want to lit up. Remember, I had to lit up 2 of them. This and this, and I also noted them exactly like I'm having it here on this LEDs. You see, C1, C2, COM4, and doing running inversely like that. It's a little bit weird, the notations and everything, but it has sense when you have the circuit diagram in front of you. And it worked. I mean, I managed to lit up all the segments. Remember, one segment is this letter. Letter D is one segment. Letter B is another segment. Letter G is another segment. So in total, is 7 segments. Okay, and the same here, the same thing here. So one segment is one guy. Is what I managed to lit up and to run it exactly by the code, exactly by this code. And actually, this went very well. I had to switch them back and forth to the case 1, 2, and 3. They were starting with 1, 2, and 3, and then I had to inverse everything a couple of times actually, because to actually fit what I'm having here, this table that I'm having it here, and also be in the same, to be exactly like I'm having it here as well, because I was picking or looking here and here in these 2 places and writing the code and figuring out what I have to do and stuff like that. Okay, so this, until I managed to write the first segment, one single segment, took me like 1.5 days, probably like that. For sure, 1 day fully. And I cannot show you per se right now. Well, I can. I believe I can. Let me actually show you. So segment you already seen it running. So, but very quickly, segment it should be the top one. And let's see if it's no, this I have to compile it. Build it, no errors, blah blah. And when I'm running it, I have to press the button. It's not running. It is not running because I have another logic probably inside it. Who knows? Yeah, definitely have something. Yeah, I must have this while inside. And a lot of stuff. It's not that easy as putting the segment here and running it, unfortunately. I have to. I believe. Yeah, exactly. So yeah, okay. Let me try it like this. So I have to take that guy there, but not while through. I have to do it like this. So now segment B to lit up instead of A. Let's see. No, yeah, that's good. And let's run it. All right. You see, segment B. Actually, I tested it at a very low speed. Right now, it's a very high speed. From this is 50 hertz right now because I calibrated it for when I was displaying number 1. And that's why right now you are seeing like 2 of them, but they are switching, alternating one another. And this is running quite fast here. You can barely see them. I can slow down milliseconds to 100 probably. Build it. And this is how I'm building stuff. I have to wait for that shit to disappear. And I hope, yeah, you see, now it's good. Now it's working as originally. I could get rid of this reset pin. I originally had this reset pin linked to the chip itself, but the code is doing the reset for me unintentionally. It's just when it's reaching number 6, it's stopping, and when I'm pressing the button or starting the program again, it is moving the other stuff again, and the next in line code that I have, and it's pretty much deleting the old one, so I don't really have to reset per se. When I'm doing this, it's switching there. But what it's doing, what you don't see actually, is you see this enable is activated. Is this red square there? When I'm pressing, it will make it so number 5. It will be blue. You see, and when it's finishing, the code is activated to red, to positive. So pretty much is enabling all this and disabling it when the code is running. When it's shifting, so you see when it's shifting, now this is the shifting, everything is disabled, and when it's reaching the last bit and is stopping adding more code, then is enabling, and actually by enabling this is able to send the signal further and actually permit this single guy open. If I'm pressing right now, nothing is lighting up here, you see, and only the proper guy is enabled when the stream of data finishes, pretty much. That's the logic. And what I wanted to say is that I get rid of that recipe, which was a bit too much complexity. So this is what I did. So as you can see, it is functional. It is functional. So this is the while thing that I did. It is running. So this is the clock when the clock is high. It's depending on this counter to 6, count to 6. If it's when it's reaching 6, it's getting out from this while. It's only counting to 6, meaning this 6 bits that is having here, and is raising the clock line. This line here is raising the clock first, is making it positive, and then is iterating, is incrementing the counter, is adding +1 to it, and it's going down one step, and then going to segment B, and where are you? Going there, and it's searching for this counter 6. When the counter 6 is some number, is going there and search for it, and is lighting up whatever it is there. So it's reaching this part, so it is repeating it, and then it's creating a clock low, meaning to negative. And this is our enable, the last data transaction. It means this line, it is enabling. But before entering into this while, I'm resetting the counter to 0 to be sure. It's starting from 0, and this is disabling this data, this enable line. So in the beginning is disabling it, and when it's finishing to 6, and when the counter reaches 6, doesn't matter if it's here inside the while loop, but only when it's reaching the number 6 is outputting, is enabling this last this line, is enabling this line. All right. So pretty much this is the code. Let me undo back to the previous code that it was. So undo. This is it. So I had this digit 1 already working, and then I start to find the code, to make the code for digit 1. So I had to literally add all this shit. I actually made two versions of code. One more easy to digest by the compiler, easy to work, and this longer one, which is having 2 digits for now, but I stopped here because on digit 2 it doesn't work. So it only works with digit 1. Digit 2 is having a lot of stuff here. So if I'm running this code, if I'm building it, right, no errors, everything is good, and of course I have to do that. And when I'm playing it, you will see again, it's doing this a little bit of flickering. You can clearly see only segment B and segment C are lit up, and not the other ones. And as you can see here in my where are you? So digit 1. In my code that I'm having here, only segment C and segment B are lit up. Okay, so this is exactly what it should be, and it is running exceptionally good. And I was very happy when I first make it finally work, because I had to do a lot of tryings and errors and everything. And then I said, let's make the second. Let me show you the other code that I made, and I have a bunch of backups here. And here, yeah, no, before this one, I believe. I first do it like this. So these are all the segments, and I made this function that is pretty much switching this another variable, count 7. You see here on the top, it's count to 6, but this is count to 7. It's also an int as well, and it's eating a ton of space, this int. Okay, so this is the second variable that is switching. So main void is run the program, and also the button run the program. Okay, and this is the run program function, and this function is getting this guy, digit 1. Probably I didn't save it. Oh shit, I didn't. Oh fuck. Or is this the other one? Let me check it. I believe this is the other one. Yeah. All right. So these are all the segments. Is the same. So I have these two variable, but under the same type int, and they are pretty much the same. And I have them declared there. And I'm skipping these segments. So I made a select segment method, and I'm iterating the count 7 there. I'm searching for count 7, and segment to execute. I have that count 7 as well, and select segment here, and is calling this guy here, but I have to put in this count 7. So segment to execute is then called from here. You see all this? It's very compact code. It's very compact. So segment to execute, and I'm providing it a number, and that number is actually the count 7, and this count 7 actually is searched here and find here which segment to open up, and it worked. It worked, I believe, for number 1. The tests that I did, I managed to open up only one segment probably, and I've seen it working. But when I tried to make the combination between the segments, it didn't want it to work. So pretty much only one half worked from here to here, I believe. I don't know what I did. I don't remember exactly what I did. But this is too much complexity. It's too much jumping around probably for the compiler, for this C compiler. So this is kind of very limited. Very limited. I mean, compared with C#, where I can jump the hell out of, I don't care, you know. Nobody cares how many jumps you make from one method to another. You know, if you make custom methods like this, you can jump like 10 of them, and nobody gives a shit. But here it is giving a shit, and it's throwing me an error. This program is too large. It's saying, let me actually do that. When I program, I believe, yeah. You see, a segment or the program is too large. This is when I'm trying to run a segment number 2. The segment number 2 is already made. So where are you? So digit 2. This digit 2 is having 1, 2, 3, 4, 5. So this is how segment number 2 is A, B, G, A, and D. So this is number 2. You see it? This is S, like an S or 2. So when I'm starting to lit up all of this shit, it's throwing me this error. But if I'm changing back to number 1, It's fine. Build. There are no problems. So and now when I'm running it, it is lighting up the proper way, guys. There. And as you can see, as before, BNC. So this is a very shitty situation where I was aware of limitation of the PIC microcontroller. So the PIC microcontroller, the memory inside this PIC microcontroller is very limited, and I knew it. It wasn't a surprise, and I was hoping to kind of weasel around this problem and push it to the limits, and the limit, this spacing limit, came a bit too fast at this point. Now there is another aspect, another view of the situation. Code optimization is called. So if I'm optimizing the code, if I'm trying to make it a bit more smaller and not eat so much space, like this is bad coding, and I know it, but it is the only code that worked, because with the other code optimization that I already did, this guy here, when I tried to jump from one method to another, well, that is very good code optimization, but for some reason this program doesn't like it to jump from method to method, too many methods. It's having like a rule or something. It's having a limit of 2 or 3 jumping from one method to another method, probably. I'm guessing here. And shit, this is a big shit, because I really wanted to make all these numbers. So I am right now extremely close. I managed to make only one single character, one single digit, the simplest digit, and the other more complex digits, nah, it doesn't have the space or the capability. I'm not sure. So I will have to stop here probably, unfortunately. And I don't know. Well, I'm also very new at this program. I really don't know how to optimize the code better than it is right now. I really try my best by making those that code optimization that you've seen already. This when it's complaining the program is too large, even on digit 1 is too large, and I try my best to make that. But there might be other solutions that I cannot see. I think there are other solutions. So for now, unfortunately, this is a fail. Shit, big shit, very big shit. I have some options. Either I will give up on the entire program project that I started here, because I kind of reached in the door of the project. I just made one step inside the project, actually seeing it working with that number 1 working there. But after that, that's it. I'm game over, because I hit the spacing limit of the chip, and the chip is too small. The memory of the chip is too small, and it doesn't permit more stuff to be added. It is my guess. I'm not exactly sure what it's doing. Probably it's I really don't think that the space of the chip is the problem. I believe it's this compiler problem. It doesn't like too much stuff to be running in the same time. Probably. I have no idea what the real problem is. If it is indeed a spacing problem, I can change the chip, the PIC, and it is a great deal for me, at least, to change the PIC to another number which is having a bigger memory, because I have to change a lot of code, a lot of the mentality of doing things is different from this very simplistic chip that I'm having here, and it's not an easy job for me to do it. But that is an option that I can consider it for the future if I plan to continue this project. Then the second solution is to optimize this C code that I'm having already here, and I don't know. I have to find some people that can do it for me, because I'm really very new to this stuff, and I don't know how to do it alone. To be absolutely sincere, I knew how to do it alone until this stage that I'm having it right now. But further than this, I'm just tired. I'm just fucking tired. Probably if I will take some breaks, and I will come back after some while. But I don't know the code optimization here in C#. And the third solution is to get back to Assembler, to my favorite and your favorite microchip assembler or microcontroller assembler in this mask, and do it like you see it here with all this beautiful stuff. This can be optimized quite well. I don't know how to code optimize in assembler very well, but I know it is a thing, and I know it can be optimized very well. You have to know it very well as well. I don't know it very well. Like I said, I am a beginner, but this is another possible solution. And all these 3 solutions are hard as fuck, at least for me. I push it so far. I push it so far alone, without any kind of help. I mean, what I discussed with my friend from England, he doesn't know this kind of programming at all. He is absolutely brand new. He knows electronics very well, but when it comes to programming, he's saying to me, this is your field, this is your pleasure, you have to deal with it. And I did deal with it as much as I could. I kind of make it, but not completely. And it's a fail, unfortunately. And I'm not happy. But I'm still bragging with what I did so far, because it is quite some work. I spent probably 1 week. I don't even remember. But I was so concentrated and so catched how to resolve these problems. And I did make it. And another solution. And again, it's very hard as well. Only to display the bits, so to transform this PIC 12F508 as a driver, as a LCD driver or segment driver, pretty much. And when I'm inserting some bits, when he's receiving some sort of program or some sort of coded signal serially on only one pin, like this input line that is he is sending with one line and one clock line, is sending the proper instructions to be deciphered there. The same thing is to use another the last 2 pins, also with a clock probably, and another line for data input serially, one by one. Bit banging is exactly what I'm doing here. Somehow to add from somewhere else to to create the character from some other device, either another PIC12F508 or some electronic magic with the logic gates, something like very complicated stuff like that. So that's the fourth option and solution that I'm thinking realistically how to implement this thing. And yeah, this is it for this part. I am very unsure at this point if I will continue it. But I did get to this point when I'm displaying number one here, BNC, and yeah, it's good. It is good. It's very complicated to drive these fuckers. It's very, very complicated, and I knew it. This is the first time when I'm actually making some progress and making some having some results, because in my previous attempts, when I attempted very long time ago, when I was younger, I couldn't drive them in any way. It was way too complicated back then. It is complicated right now, but back then it was way over my head. Right now, I'm very happy that I learned a little bit more about logic gates, and I am quite proficient. I know how to deal with them quite well. I work with them, and I have a little bit more experience than before, and I'm not that afraid of them. Before I was afraid of logic gates and how to use them. There were some mystical stuff, but now I see their potential. I see how they can help me, and it's a good thing to learn it. And I'm telling to others as well, the guys, anyone that is watching my awesome movies that I'm making, to take the time and learn these logic gates, because they are interesting and they will help you. Also use a good simulator like I'm using here, the Proteus simulator, or the breadboard in reality. Play it in reality if you don't have the simulator. But the simulator will help you a lot. Also, be aware, every simulator is having a lot of bugs, and you have to learn those bugs and get over them. And learn them, get over them, and do your stuff, and it will pay off. I mean, what you are seeing here is not simply just I'm putting that and that, I'm connecting that and that and that, and it's working just from the first try. Sometimes it does, but many times it doesn't, and I have to fight, to do a real fight, like in the Matrix, with the bugs that the program is having, and I have to deal with those bugs, and I kind of learned them all, and I kind of know what to avoid and not to use, and what to use, and everything. All right, this is it for this part, which is a failure, unfortunately, but it's a good failure in the sense that I managed to push it to this far, like never before. And I couldn't do it before, ever. But this is the first time, and I kind of failed, but in a good way. All right, pray or hope that I will continue this project, because I am extremely inclined to give up on it and just don't care about it anymore, because it's too much. It's way too much. It's way too much. All right, thank you very much from your favorite artist, Mr. Q12 here. Thank you for watching. Thank you for pressing the like button there, and see you later, hopefully, on my next project or my next update. Who knows? Bye bye from Romania.